Well, hi guys. This is the very last lesson of the algebra um, chapters before we take your state test. This is your statistics lesson. Statistics is going to have a lot to do with mean, median, range, and a lot of different plots, three different types of graphs that don't look like an XY graph. They look different than that. So, statistics is just the branch of mathematics that deals with organizing data, analyzing data, all of that stuff in the real world. So, this is where you're going to get a real world application for a lot of stuff. Your mean is just the average value. So, when you find your average of things, you just add all of your numbers up. So, like 57, 72, and divide by how many there are. We are going to be able to find this in a calculator without doing all of this work. And when we find it, it's going to be an X with a little bitty bar over it. We call it X bar. The median is the middle of all of your data, the very center of it. We're going to call it Q2, and I will explain that in just a second, why that's Q2. But your data does have to be in order for that to find your median. So it can't be like 5, 10, 7, 2, 12. Those numbers have to be in order to find your median. Your range is the spread of all the data. So like those numbers I just gave you, 2, 5, 7, 10, and 12. The range is from 2 to 12. When we do this in stats, we're actually going to subtract them. So 12 minus 2 would be that 10. That would be your range. You don't have to do like 2 less than or equal to y less than or equal to 12. We don't do that in stats. We just subtract them. Okay, a quartile. So a quartile, we divide our information up into 4 different quarters. Like there's 4 quarters in a dollar, so there's 4 quarters in our information, in our data. Q1 is the median of the lower half, so this is your halfway point. So Q1 is the median of that, so median for the low half. Q3 is the median for the upper half. And you have your min, which is the absolute lowest, your max, which is the absolute highest, and then Q2. I told you up here on median we would come back to Q2. We're splitting this up into 4 quarters, so you have Q1, Q2, Q3. Technically this is Q4, we just don't call it that. So that Q2, that's your second quartile. That is your median. That's why we also call it Q2, because it falls in the middle of our quartiles. So it'll get called Q2 more than anything else. Your inner quartile range is the same thing as range. You're still going to take your lowest number, highest number, but we're going to work on the inside of the numbers. So not your max and min. Change the color. So we're not looking at max and min for that. We're looking at the middle numbers. So your lowest and highest here are going to be Q1 and Q3. Those are the numbers you would subtract here. And we'll see all this as we're working the problems out. This will just give you an overview of what you're going to see. If your graph or your plot or whatever we're looking at is skewed, it can be skewed to the left, which means all your data is over on the right, but your tail comes off to the left. It like slides off to the left. If it's skewed to the right, that means it's going to slide off to the right. That's where your tail is going to be. All your data is on the left, but it slides off to the right. And then if it's symmetrical, it's going to be pretty perfect on both sides. There may be a little difference on both sides, like this one might be here instead of even, but overall, it's going to be very, very similar on both sides. Okay, the last thing is outlier. This is a value that is so extremely high or low in the data that it's set apart. It's 1.5 times your inner quartile range. So if your interquartile range was like 10, you would just multiply 1.5 by that. So 1.5 times 10, and it would be 15, which means if you had an outlier, it's going to fall below 15 over here, and it's going to fall above 15 on this side, 15 units away from the middle. So 15 units away from on the lower side and 15 units away on the upper side. These are just numbers that are super far away. So if we had data that was like 5, the numbers I gave you earlier, 5, 7, 10, 12, and then I randomly threw in a 43. That 43 is super far away than the rest of these numbers. That's what we call an outlier. It doesn't fit in the data. So it just sits on the outside. Like this is your city or your house, and this is sitting outside your house. It is not related to the rest of these numbers. It's still in the data, it's just not in those numbers. It doesn't fit very well. Okay, so we're going to find all of this information in the calculator. We're not going to make you find this out by hand. So if we look at the first example, there are 30 people were asked to rate the TV series Doctor Who, where 1 was the least favorite and 10 was the favorite show. Their ratings are listed below. So all of these numbers are their ratings. We have 30 numbers here. We're going to enter the data into STAT. So we know STAT. We've done this. We're going to go to STAT, edit your table, and you're going to enter all of these numbers into STAT. So make sure you get all 30. So 3, 10, 4, 6, 5, 7, 3, oops, not 36, 3, 6, 5, 2, 4, 6, 7, 5, 10, 4, 1, 7, 3, 5, 7, 4, 3, 9, 5, 2, 9, and 5. I missed something somewhere. So if you have 30 people, that means there should be 30 numbers above this. We're sitting at 30 right now, which means we missed a number somewhere. So I'm going to work it backward to see where we missed a number. So we have 5, 9. That's supposed to be a 3. So we missed a 3 up there. So I'm going to do 3 and then 9, 5. So if you miss a number, you need to make sure you go back and get it. There should be 30 numbers above where it says L131. This means we're on the 31st number, and we don't have a 31st number, that's why it's blank. So make sure you have 30 numbers above this. So once we plug it into STAT, this is not linear, so we're not going to do STAT over number 4. It's not quadratic. It's none of that stuff. This is just a list of data. We're not trying to find an equation for it. We just want to find the mean, median, mode, and all the quartiles. So what we're going to do once we have that plugged in, we're going to hit STAT, and we're going to calculate our answer for one variant stats. So just number 1 right here, because we only have in a list for L1. So we're not looking for L1 and L2. We're not looking for an equation. So calculate that, and you'll get this big long list of numbers. Everything in here means something. The ones we're going to focus on are this X bar, this first one. And if you remember back in the vocab, that X bar means our mean. This is your average of all of those numbers. So our mean is 5.3. Change colors. Your median, for that, you're going to look at Q2. Q2 is also our median. Oh, crap. Let me get back to that. So you're going to have to scroll down. There's more information if you scroll down on your screen. So your median, oh, it says median. Thought it said Q2. It says median, so our median is 5. Now your mode is not going to be on this list. Your mode is the number that is used the most. So you can go through and count all of these up, or your calculator can put them in order for you, so you don't have to look at this stuff and try to count it up. If you go back to Stat and you click Sort A, so number 2 right here, you want to sort our first list. We put all these in L1. So we want to sort L1. To get to L1, you're going to hit second, number 1. That'll sort L1. And then just hit enter. So when you go back to your list on Stat, all of these are going to be in order for you. You got the 1, the 2, least to greatest, all of this. It'll all be in order. So which one has the most numbers? So 1 only has 1. 2 has 2. 3 has 1, 2, 3, 4, 5. So that's a lot. We'll hold on to that one. 4 has 1, 2, 3, 4. Only 4 for 4. 5 has 1, 2, 3, 4, 5, 6. So 6 for 5. So that's our highest so far. 7 has 6. 6 has 1, 2, 3. Only 3 for 6, so that's not it. 7 has 1, 2, 3, 4. So not 7. And then 9 has 1, 2, 3. Only 3. And then 10 has 2. So the highest one we had here was 5. It had 7 on it. Sorry, it had 6. So you can put them in order so your table can tell you the mode. Again, the mode's not going to be in the calculator. This is just which one has the most numbers in it. And the most were 5. Okay, your 5 number summary. This is what you're going to get asked about most of the time. So when we do that Stat Calc 1, if you didn't go off that screen like I did, this is going to be the bottom of that screen. The min, the Q1, the Q2, which is called median, the Q3, and the Q4, which is called max. That's your 5 number summary. So we're going to write those down. Our min is 1, Q1 is 3, Q2, which is your median, that is 5, Q3 is 7, and your max is 10. So to calculate the range, if you go back up to your definitions, this is your max minus your min. So our max is 10, our min is 1, so 10 minus 1 is 9. So that's your range. You have a range of 9 that's spread over 9 different numbers. The IQR, that's the inner quartile range. So you don't care about the lowest and top. You want the inside of the range. For that, you're going to look at the max and min of the inside, which is going to be your Q3 minus your Q1. So our Q1 is 3. Our Q3 is 7. So 7 minus 3 is 4. So your inner quartile range is spread out over 4 numbers. Now these numbers don't really mean a lot to us right now. Like, whatever, they're numbers. What we use these for are the different types of plots we can have, the different type of representations we can use. So on the next page, we have all of our representations. We have dot plots, we have histograms, and we have box plots, which some people call box and whiskers. Our dot plot. This is, we're going to draw each occurrence in a dot. So every occurrence you have here, you're going to put a dot on your graph. So we have a 1, so I'm going to put a dot for 1. We have 2 2s, so 2 dots. 1, 2, 3, 4, 5 3s, so 5 dots. 1, 2, 3, 4 fours, so 4 dots. 1, 2, 3, 4, 5, 6 fives, so 6 of those. 1, 2, 3 sixes. 1, 2, 3, 4 sevens. Ooh, no eights, so 8's not going to get a dot. 1, 2, 3 nines. And 2 tens. So that's a dot plot. For every number you have here, you're going to put a dot in the appropriate place. This gives us all the detail we need. We can see where everything is. We can see the mode. We could figure out the median, all of that stuff, the max, the min, everything. And this can be used to calculate statistical values like the mean, the median, the mode, the range, all of that stuff. It also shows us where the gaps are. Like we clearly had a gap on 8. There was no number on 8. So there's a gap there. We can see we didn't have a single 8. It shows us the centers, which mean mean, median, and mode. We can add all of these up and divide by 30 to get that mean. We could, there's 30 numbers, so the median is halfway. Half of 30 is 15, so we could count to 15 and figure out where the median is. So we could do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So our median is going to be 5. And we can see the mode, which means the most. Which one of those had the most? Well, 5 had 6 dots, so that one's the most. You can also see the spread, which is the range. So your range is your min minus your max. Nope, sorry, your max minus your min.
Teachers, please excuse the interruption. At this time, the dance team needs to report to Coach Burke's room, B100, and any returning cheerleaders need to go to the locker room for pictures. The dance team needs to go to Coach Burke's room, B100, and returning cheerleaders need to go to the locker room for pictures. Also, third lunch grab and go orange may head to the cafeteria at this time.
Well, that took forever. Okay, anyway, so your range again is your max minus your min. So you can see the highest number on the list was 10, the lowest number was 1. So 10 minus 1 gives you a range of 9. You can also see the shape, if it's symmetrical or skewed. So if we were to draw a little curve around this, you can see if the tail goes off to the left, to the right. This one's pretty even because your highest number falls about halfway, and then there's about the same number of dots on either side. So this one's pretty symmetrical. It's not perfect, and we're not trying to find it to be perfect. We're just trying to figure out what is the best. And the best for this one's going to be symmetrical because there's about the same on either side. So that's what you can see from a dot plot. For a histogram is just like a bar plot. So you'll have a lot of bars here. That'll tell you how much is in each section. To get that, they usually give us the frequency table. This is the frequency from the first page, those 30 numbers we had on the front. So each bar shows the number of occurrences for each interval. So between 0 and 1, we only had one number on the front page. So we only color in one box. For 2 to 3, we had 7 numbers. And we have those numbers at the top. We can look at them. So we had one number for 0 to 1. For 2 to 3, we have 7 numbers. So we're going to go all the way up to 7 and draw that box. I like to color it in. You don't have to, but I like to. 4 to 5, there were 10 of those. So we're going to go all the way up to 10. For 6 to 7, let's see, there were 7 of those. That's what our frequency table tells us. So we'll stop at 7 there. For 8 to 9, there were 3 of those because we didn't have any 8s. We just had 3 9s. And then he gives us 9 to 10. 9 is in 2 spots. Sometimes they make little mistakes like this, but if you look at your frequency table, you can clearly see those 9s, those 3 9s, are being counted between 8 and 9. They're not being counted here. So technically this last one is just 10. They do that sometimes. I'm not exactly sure why, but I think it's just a mistake. But they're clearly counting the 9s up here. So this is just 10s. And we had 2 10s. So we'll color in 2 spots. So that's a histogram. You can see how many are in each row. And the detail is masked by intervals. So you can see the intervals are just 0 to 1, 2 to 3, 4 to 5. So you can't see exactly how many 4s we had or exactly how many 5s. You just know there were 10 between 4 and 5. But you have no idea how many of each there are. So it makes the data a little bit more obscure, where you can't really tell a lot of information. It will show you if there's any gaps. So if any of those had been empty, there would have been a gap. You also can find the median. So again, there were 30 numbers. So the median is halfway, so half of 30 is 15. So we would just count up to 15. 1 plus 7 is 8. And then that plus 10 is 18, which means our median is going to fall somewhere in here. It's going to be between 4 and 5. There's no way to tell exactly if it's 4 or 5. We just know it's going to be 4 or 5. You can still find your range. You can see your highest number was 9 and 10. Your lowest number was 0 or 1. So you can still subtract those. You just do your highest is 10, your lowest is 0. So 10 minus 0 is 0. 10 minus 0 is 10. It skews your range a little bit because your range is actually 9 because they included 0. So it's not going to be perfect as a dot plot, but you can still get an estimate of your range from it. And then your shape, you can definitely see if it's symmetrical or not. So you can see it's almost perfect. This one had a couple extra numbers, but overall pretty symmetrical. If it was skewed, it would have a really big tail out on this side, or a really big tail first before it went over. This one's pretty perfect. So that's still pretty symmetrical. The last kind we can have between those 30 numbers is a box and whisker plot, or box plot. This is where we use those 5 number summaries. You're going to have your minimum, all from your calculator. Your minimum, your Q1, your Q2, which is your median, your Q3, and your max. So you can draw this out. We'll put a line at our min, a line at our Q1, which is 3. Our median was 5. Our Q3 is 7. And our max is 10. To make the box and whiskers, your box is going to enclose your middle numbers, and then your whiskers extend to the edges. So you have a box and whiskers. For this, it doesn't really give you a lot of data. The only data you can tell from this is your highest and lowest number. That is it. We know it goes from 1 to 10. We have no idea what actual numbers were in the data unless they gave us the list. We don't know if 4 was in there. Remember, 8 wasn't in our data. 8 wasn't up here in our list of numbers. But yet it's on our box plot. It's in the line. So it can't tell you exactly what's in the data except the min and max. You can find the median. The median is the middle of that box. You can tell quartiles. So you have your Q1, your Q2, your Q3, and technically this is Q4. We just call it the max. So this first little section is 25% of your data. That's 1/4. This is another 25% of your data. That's 2/4 overall. The next one is 25% of your data. That'll give you your 3/4. And the last one is another 25%. That'll give you up to 4/4. We can't do anything other than 25% intervals. Like I can't tell where 10% falls. I can only tell 25%. So you could do 50. Those are increments of 25. You could do 75. So if I start here, I could go to the end. That's 75%. But we can't do anything other than 25% quartiles. It is not possible to find any other information. You can find your range. Your range is just your max minus your min. So your 10 minus 1, range, 10 minus 1, which is still 9. Your inner quartile range is the range of the box. So we do our Q3 minus our Q1. So we have 7 minus 3, which is 4, which is what we got on the front of this worksheet. And you can still tell if it's symmetrical. So if you look at this box, it's pretty even down the middle. So the boxes are about the same size, the whiskers are about the same size. It's pretty symmetrical. When it's skewed, it's going to have like a box. And then one line will be like super long on either side. That's what skewed looks like. But this one's pretty symmetrical. So these are skewed. So those are our 3 types of graphs. We have dot plots, we have histograms, and we have box and whiskers. You can do data with any of these types of plots. Okay, a little bit more vocab. When we're looking at centers, they're talking about the mean, the median, and the mode. The median divides it in half. That's your halfway point of your data. So you have 50% above it and 50% below it. The spread is the measure of the variation of the data. You want to look at your range and your interquartile range for that. If the spread is smaller, you're going to have less variation, which means it's more consistent. And then your shape can be symmetrical if it's pretty centered and evenly distributed around a median. Or you can have it skewed left, which means you're going to have a tail on the left. So all your data is going to be over here. Or it can be skewed right, where you're going to have a tail on the right, and all your data is going to be on the left. So it just depends on where your tail is. So let's try some. So example 1. Okay. So the double dot plot shows the number of points scored by Sam and Daniel in 15 basketball games. Enter the data for each player into your calculator. So I'm going to go to Stat. I'm going to edit my table. To clear it, I'm going to go up, clear, enter. That'll clear the whole table. We already have Daniel's information, so I'm not going to plug his in. I'm going to get Sam's information. So dot plots are really nice because you know what number it is and you know how many of that number there are. So we have 1 4, so I'm going to put 4. We have a 6. We have 2 8s, so I'm going to put 2 8s. 2 10s. 3 12s.
Third lunch, blue dine-in.
2 14s. 2 16s. 1 18. And 1 20. And we can double check ourselves. We said we were looking at 15 basketball games. So the blank that we're sitting at should be number 16. There should be 15 numbers above that. So if I look at my L1 parenthesis, that says we're on number 16, which is correct. 16 should be blank because we only have 15 basketball games. So I know I got every single number in there. Okay, then we're going to hit Stat, go over to Calc, and we want to do one variant stats. And just enter through that, and we'll get that big old table of information. This X bar, that is your mean. So our mean right here is 12. Daniel's mean was 16. Sam's mean is going to be 12. For the rest of it, we need the bottom of this information. So our min is 4. Our Q1 is 8. Our Q2, which is called your median, that's 12. That's your median. Our Q3 is 16. And our max is 20. So we want to find the range and the IQR, which is the interquartile range, for each player. Your range, again, is your max minus your min. So for Daniel, that means 24 minus 8, which is 16. For Sam, on his range, that's going to be 20 minus 4, which is also 16. Your interquartile range is the inside of your data, where we make that box on a box plot. That's going to be your Q3 minus Q1. So for Daniel, that means 20 minus 12, which is 8. And for Sam, that means 16 minus 8, which is 8. So compare the centers. Compare their mean, their median, their mode. So for the mean, one second. Daniel's mean is that little X bar. Daniel's mean is 16. Sam's mean was 12. For the median, that's your Q2. Daniel's median was 16, and Sam's median was 12. Your mode is the highest number that they have. So Daniel, the highest one he had, the one that had the most numbers, was 16. And Sam, the one that had the most, was 12. So they're all the same. So which one is generally a higher scorer? Overall, it's going to be Daniel, because all of his scores were higher. So compare the spreads, the range and the interquartile range. Which one was more consistent? Which means there's less variation, which means it's going to have a smaller number. So it's less spread out. So if we look at their range, Daniel had a range of 16. Sam had a range of 16. So they were the same. So that's not going to tell us which one is more consistent because they're exactly the same. So let's look at their interquartile range. Daniel's was 8 and Sam's was 8. So again, same exact. So neither one of them is more consistent than the other. They're exactly the same. Both of them have the same variation. Okay, what about the shapes of their graph? So if we go up here to their dot plots, we draw a little shape. Does his have a tail on one side or is it pretty symmetrical? That one's pretty even, actually perfect. You have 3, then you had 2 2s, then you had 2 1s. So that's actually perfect. That is symmetrical. Same thing for Sam. I'm going to draw a little curve. Which side does he have a tail on, or is it pretty symmetrical? Again, this one's actually perfectly symmetrical. You have 3 in the middle, 2 2s on either side, and then 2 1s on either side. So he's symmetrical as well. So that's how you get information from a dot plot. So let's try a histogram. So the histogram shows the daily high temperatures for two towns over a 50-day period. So we're looking at 50 days here. Their temperatures range from 30 to 39 all the way up to 80 to 89. And those ranges go up here as well. So those temperatures match both the graphs. So we want to label each bar with the approximate number of days. So if we look at town A, for 30 to 39, how many days were here? Nothing. There's nothing there. So that's a gap. That's 0. How many days for 40 to 49? That one has 4. 50 to 59 lands at 8. 60 to 69 lands at 10. 70 to 79 is at 16. I'm just following across. 80 to 89 lands at 12. Okay, what about town B? 30 to 39 lands at 2. 40 to 49. Ooh, that one's in the center. What's in the middle of 6 and 8? Well, 7. So that one's 7. 50 to 59 is 14. 60 to 69. Ooh, again, that one's in the center. What's between 14 and 16? 15. 70 to 79, again, is in the center, which we already called that 7 earlier. And 80 to 89, kind of hard to tell, but that one's in the center as well if you follow it over. So that one's going to be 5, between 4 and 6. So find the median temperature. So the median is going to be halfway. Half of 50 days is 25. So we want to find the 25th day. So we can add these up. 0 plus 4, that's 4. Plus 8 is 12. Plus 10 is 22. Plus 16 is 38. So we know 25 is going to fall somewhere in here, in that 70 to 79 marker. So we don't know the exact temperature because they didn't give us that information. We just know it's going to be somewhere in this box. So between 70 to 79. So we can do the same thing for town B. 2 plus 7, that's 9 days. We need to reach 25. So add our 14. It's 23 days. So we need to go a little over 14. So we need to go to the next box. And that'll give us 38, which is too much, but that means we passed 25 in here. So 25 is going to fall in this box, which happens to be 60 to 69. So between 60 to 69 temperatures, degrees. Okay, for C, what percentage of days was the temperature above 80? So for town A, 80 to 89 falls here. Oh, I erased my numbers. What was that? That was 12. So 12 days are in the 80 to 89 range. So we know 12 days. This goes back to probability, the last lesson we did. Out of how many? We know 12 days were between 80 and 89, but out of how many? That 50-day period. So if we do 12 divided by 50, we're going to get 0.24. And then for a percentage, you just move it over twice, which gives you 24%. So 24% of your days are above 80 degrees. So what about town B? What percentage was below 50? So 50 falls right here. So below that, what were these? 7 and 2. So all of these are below 50, which gives us 9 days out of how many? That 50-day period. So 9 divided by 50 gives us 0.18. Move that decimal over twice, so that is 18%. Okay, and last two. Describe the shape of town A's histogram. So for town A, we draw a little shape here. Our top, where most of our data is going to be, is on the right. And we have this really long tail, this really long slide out here to the left. And then there's not much of a slide over here at all. So because we have that really long tail on the left, this is skewed left. Because that's where your tail is. That's how you tell. All of your data, your highest point is over here, and then it falls off to the left. Which one is more likely to have a mean closer to the median? For this one, we know our median for A was in this box. Our median for B was between 60 and 69. Your mean is going to be kind of close to that, but depending on how it's skewed, it's going to change where your median is. If it's skewed left, your mean is going to be less than your median. If it's skewed if it's skewed right, your mean is going to be more than your median. So if we look at these graphs, we already talked about the first one being skewed left, which means our mean is definitely going to be less than the median. It's not going to be perfect. If we look at town B, our data falls about here. So the top of it's about here. We said our median was between 60 and 69. So that data is actually pretty symmetrical. It's a little bit off on one side, but not too much. These lines actually happen to be perfect. These are super close. Your median's gonna fall, your mean is gonna fall somewhere in here, which is not gonna be too far away from your median. So this one's actually gonna be really, really close. Because of this skew that just kind of falls off, that mean is going to be somewhere way over here. It's going to be super far away because it just falls off an edge. So the closer related they are, the more symmetrical it is, the closer they're going to be. So this is definitely going to be town B. It's a lot harder to see on a histogram. Those are really easy to see with dot plots. So we just do the best we can with the information that we're given. Okay, example 3. Let's look at some box plots. So if we want to create a box plot, I gave you a whole new list of numbers. We're going to use the calculator to find the values. So that's not right. So we're going to go back to stat, enter your table. So clear out what we have. We have 10, 12, 14, 17, 17 again, 18, 2 19s, 20, 22, and 25. And we can get all of this information from the calculator. So we can do stat, I think I'm missing a number. Let me make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I'm at 12. Yes. So I have 11 numbers there. Perfect. So we do stat over to calc, number 1, enter through that and calculate. So our x bar, which is our mean, That is 17.55. Then if we scroll down on that list, our min is 10. Our Q1 is 14. Our Q2, which is also called the median, that is 18. Q3 is 20. And then your max is 25. To get your range, again, we do max minus min. So 25 minus 20. Oops, not the right spot. Which is 5. Sorry, not 25 minus 20. What? 25 minus 10, which is 15. Sorry. And then your IQR, your interquartile range, is your Q3 minus Q1. So that is 20 minus 14, which is 6. So we can actually see these box plots in our calculator. We don't actually have to draw it. So what you're going to do is you're going to go to second y equals. You're going to use this first plot, click on that, and turn it on. Go down to type, and we want a box plot. So we're going to get this second box plot. I'll show you this first one in a second. But we're going to get the second box plot. Enter on that. And then to see it, if you hit graph, it's not going to do anything. To see it, you have to hit zoom. And we want to zoom our statistics. So zoom stat. So number 9. And that'll give us our box plot. So if you hit trace, it'll show you all the boxes. We can see our median is 18. Our Q1 is 14, min is 10, Q3 is 20, max, our max is 25, which matches everything we got up here. So we can label all that on our paper. So this was our Q1, which was, I already forgot, 10. Sorry. That's not our Q1. That's our min, which was 10. This is our Q1, our Q2, our Q3, and our max. So 14, 18, 20, and 25. 14, 18, 20, 25. So that's what we get from the calculator, which again is exactly what we got up here when we plugged it all in. So if you wanted to see an outlier, I can definitely show you that. So I'm going to add an outlier. I'm going to go to stat, and on the bottom of my table, I'm going to add a 1. So all of our numbers ranged from 10 to 25. So 1 is very far away from those. So if I go back to the box plot, I'm going to see that it changed the shape of my graph. Now this is where I'm going to go show you the outlier. If we go to the box plot 1, and we use that first little graph, the first little box plot right there. On that graph, it's not working. Did I not click enter? I did not. I did. 09. There it is. Okay, I just hit enter. Okay, you can see that you still have your box plot over here. You still, but you're going to have an outlier on the other side because we put in that 1. Because we put in that 1, if you check your 5-number summary, you have that 1 down there at the bottom. That's your outlier. Your min is still 10. Your Q1 is now 13. Your Q2 is 17.5. Your Q3 is 19.5. and your Q4 is still 25. Your max and min are never going to change, but those interquartile numbers, those are going to change a lot based on what the outlier is. So for the first plot, the middle 50 ranged between 14 and 20. For the second plot, the middle 50%, the two middle quartiles, ranged between 13 and 19.5. So it adjusts and skews our data a little bit. So we have to be very careful with outliers and watch those very closely. So let's try one. Let's try to get some information from one of them. So the coach at Marshall College compiled information about the heights and inches of basketball players as part of the paperwork for an upcoming tournament. Both teams of the college have 14 members, so we know they have 14 people. The data is shown below. So we have Team A, you have their min, their max. Team B, their min and max. Min and max are the only numbers we know 100% are in our data. Everything else is a guess. Even the median, even Q1 and Q3, those are not necessarily values of our data. We can't be 100% sure. Just because a line falls on 72 doesn't mean somebody reached 72. The only numbers we know for sure are the min and the max. This is just giving us a range of everything else. So if we label all this, which I kind of already did, that's your min, this is your Q1, Q2, which is your median, and Q3. Same thing here, Q1, Q2, which is our median, and Q3. Which one has a higher median? We can compare the values of any of these. There are certain things we can compare and certain things we can't. This is going to tell you what we can and can't compare. We can compare the values of any of those 5 numbers. So which one has the higher median? Well, Team A has a median at 80.5. Team B has a median at 70. So Team A is going to have a higher median. Which one has the shortest player? Shortest is asking for the men. So Team A was 73. Team B was 69. Which one is shorter? Team B. I'm going to pull this up again because all the rest of it's on the next page. Give me 1 second. Okay, all of this is on a second page, so I need to just fix this real quick. Why is it so... There we go. Okay, so for part C, and I'll go back to the graph, the lower 50% of the players in Team A are shorter than the lower 50% of Team B. So if we look at the lower 50, so this one is 25%, this one is 25%, that's the lower 50. So from 80.5 down to 73. Same thing here. Each one of these in the box, they're all 25%. So this is 50%. So 79 to 69. So it said, the lower 50 of A is shorter than the lower 50 of B. So the lower 50 of A ranged from 73 to 80. B ranged from 69 to 79. Which one is shorter overall? B is shorter. They go all the way down to 69 and they only reach 79. A started at 73, that's a lot higher, and stopped at 80, which is still higher. So it's definitely going to be Team B is shorter. Get rid of all this. Oops. So this is false. They are not. Team A is not shorter. Team B was shorter. So you can compare their percentages. We can only compare percentages. Mess it up. We can only compare percentages in 25%. Only in increments of 25%. Never like 10 or 15 or 20. It has to be 25%. So 25, 50, 75, and 100. Because that's all we have here. We have each one of these is 25%. That's all we know. Okay, we can also compare the spreads. The spreads are the range and the inner quartile range. So for Team A, what's their range? That's just their max minus the min. So their max was 84 minus 73, which is 11. Their inner, I'll go ahead and do Team B. What's their max minus their min? So 85 minus 69, which is going to be 16. And then the inner quartile range, that is the box. That's Q3 minus Q1. That's your max and min of the box. So 82 minus 79 for Team A, which is 3. And for Team B, the box is 82 minus 74. 82 minus 74, which is 8. So which team has a greater variation? Which numbers are spread out more, which means they have a higher range or higher interquartile range? Definitely B. Those were 16 and 8, where A was only 11 and 3. So those are more consistent. So Team B is more varied. They have a greater variation. They're spread out more. And you can see that from the actual list. This one is a lot bigger than this little bitty plot right here. So they're spread out a lot more. Okay, which team is consistently taller? So if we go back to this, if you look at the tallness, you can look at the box, the max, all of that. This box is stands a lot taller than the bottom, than B, because B goes all the way down to 74, and this one only goes to 79. They both stop at the same place. They're both at 82, but overall, A is taller than this 74 that B goes down to. So it's definitely Team A. Okay, describe the shape for the plot of Team A. So this is your symmetrical or skewed left or skewed right. So you can't really make a little curve on this one. The box does that for you. This is your curve. This is the top of the curve. Where does your tail go? Is there a tail off to the left or a tail off to the right? The tail goes super far off to the left. So this one is 100% skewed left because that's where your tail is. Oops, wrong page. So this is skewed left. Okay, what about for Team B? Ugh, why do I keep doing that? Okay, let me get this real quick. So again, for that little bitty mountain of where the tail is, that's always going to fall on your median. So what about the tail for this? Is there a really big difference between the tails? There's kind of a difference between the tails. This side is a little bit longer, but not to the point that it's a major difference. Like this one, the tail was super long, and this one was really short. This one's a little bit longer, but it's not a major difference. So that one was more symmetrical. It's a little bit harder to tell, but it is definitely more symmetrical than A. They're both kind of left, but you can see that A is like very, very left. So B is more symmetrical. Okay, and then remember when you're looking at box plots, you don't really know any details except that there are 14 people within that box plot and the height of the shortest and tallest people. If we're looking at A, 77 is technically in my box plot. I do not know if somebody is 77 inches tall. I know someone's 73. I know someone's 84 because that's my max and min, but I don't know if 77 is somebody. I actually don't even know if these are true because those are just averages. So the only numbers you know for sure are your min and your max. Everything else is a complete guess. So the only thing you know for sure are your min, your max, and that we have 14 people within these box plots. So the question says there are 5 players on Team B that are at least 74 inches tall. And I have no way to tell where 5 players land. So on Team B, 74 is right here, but are there 5 players in this list right here? I have no idea. I know there's some because there's a whole big box right there, and I know my max is a player, but I have no idea if there are 5 people in here. There might be 10. There might be 12. I'm not exactly sure. We can't tell how many are where. We can just tell, again, the shortest, which is the min, the tallest, which is the max, and that there are 14 people overall. But that's all we can tell. So this cannot be determined.
Juniors and seniors class range.
There's not really a ton of information you can get from box plots other than your quartiles, your 25%, and the number of players and the max and min. So be very careful when you answer questions about box plots. So try your practice and then make sure you're getting ready for your state test next week. Good luck.